Okay, so today 1.5 solving equations. We're going to solve in graph inequalities, and we're going to write and solve compound inequalities. All that a compound inequality means is that you're going to have two instead of one inequality. Okay, so no big deal. You guys may or may not remember from doing inequalities in the past. We have and or inequalities. Those are the compound ones. We'll talk about that later in the lesson. Do not write this whole chart down. We're just going to kind of talk about it, and you write down whatever you need to write down. Right? I'm a huge proponent of you being efficient in the work you do, especially in the notes you take, because these notes will be posted, so if you realize, like, oh crap, I want to go back and write a little more down there, you can always look back at the notes and do so. First thing that we need to talk about, and I'm actually going to go to a new page to talk about that. So some of you guys, anyone have a little bit of dyslexia, or like it could be massively dyslexic? Because I do. Anybody else? Right? We're always open and honest here. Like you could be, when I'm really tired, like this week has just absolutely kicked my ass. Because of all the craziness going on in our world, as well as teaching online makes me more tired. As I said, like when you guys are in person, I feel your energy and it helps me become energized. When I'm looking at your silent little happy faces there, there's not a whole lot of energy to be had. So if you have any dyslexia and I'm asking you which one's less and which one's greater, that produces some anxiety because you don't know. Right? When I first learned in, like, I don't even remember. You remember when you learned which is your left and right hand? And how many people had trouble learning their left from the right hand? It's a really good indication that you might have a little dyslexia if you had trouble with that. So I'll never forget early on in school, like first, second grade, my teacher going like the old L trick. And I have to do it backwards so they're faced the right way. They're like, oh, look at the L, can't you tell? And I'm like, no, jackass, I have dyslexia, so I can't tell. Like, that's ridiculous. Give me a different strategy. And they couldn't. So what I did, being my little, whatever, the kid that I was like, I got to figure out a way I can tell my left from my right hand. So I am right-handed. I write with my right hand. That's one way I can remember that was my right hand. I'm an athlete. I love to play sports. So throwing a ball, I could remember that was my right hand. So why the hell would I go through that whole long dissertation of left and right hand? Because you can use your left and right hand to determine what's less and what's greater than. So if I take my left hand, I put it on the screen right next to this less than sign, and I turn it diagonal, it makes a less than sign. So if you ever get confused which is less, which is greater, because you have to look at this and tell me if it's less or greater, like write it with a statement. That's a great way to tell. Left hand, turn it sideways, kind of diagonal, that makes a less than sign, right? You could literally draw it on your hand and make a less than sign. So if you ever struggle, the difference between less and greater, that's a strategy to help you through that. So this one, these two right here on top, the greater and less than, they both have open dots. So this is greater. This one's less. The top two have open, the bottom two have closed dots. So I don't know if you even remember when you graph these things, you have to make an open or closed dot. You got to remember all the way back 2 years ago to Algebra 1 to kind of jostle your memory. I was struggling, like I had these students, they were Algebra 2 students, a couple of kids that just could not figure out when it was going to be an open or closed dot. And I'm racking my brain trying to figure out, like, to me it seems obvious. If it seems obvious to you, that's great, right? You get it easily. But it's not obvious to everyone. So this girl finally came up with what I thought was the stupidest strategy I've ever heard in my life, but it totally works for students, okay? So if I look at the difference between this one and this one, greater than or equal to, this girl goes, oh, I got it, Evans. This one right here, It has more stuff because it's got the equal to. So that's how she realized that it was a closed stop. Less stuff up here, more stuff down here. Less stuff open dot, more stuff closed dot. Stupidest reason ever. If that works for you, fantastic. I like to explain it as well, right? That's like a shortcut method, and we'll explain it as we graph some of these. But if you have greater than or equal to, or less than or equal to, the reason it's a closed dot is because it includes the number. So it's like 4 or greater. It's 4 or less. So the closed dot represents the 4 is in the solution set. So if it's greater, let's just write one. If it's x is greater than or equal to 4, like that, and I graph it, when you graph, I'm not the kind of teacher that wants you to number your number line like -10 to +10. Why? Because that's a waste of time. So if I'm graphing x is greater than or equal to 4, all I want you to write is the 4. When you graph this thing, I always want you to draw your arrow above the number line. So I'm going to have a closed dot here. Why is it closed? It's closed because I have more stuff. I have the greater than and the equal to. That's what makes the dot close. And then when I draw my arrow, you'll notice that the inequality and the arrow point the same way. That only works if your variable is on the left. So your variable has to be on the left to use that strategy. Many teachers won't teach you that strategy because they think you're too stupid to remember that strategy. I don't think so. I think you can remember to put the variable on the left and know that the inequality arrow and the arrow on your number line are going to point the same way. Variable on the left, they point the same way. So what invariably happens then? Of course, you'll get a problem. We'll do a negative. Oh, I didn't mean to do it that way. Sorry. Hold on. Let's say we had something like, let's say we had something like -2 is greater than x. So, oh God, the variable's on the wrong side of the inequality. So how do you rewrite this inequality then? My little helpful hint for that sort of deal is we want to flip everything. Okay, when we flip everything, here's what I mean. We take the x that was on the right, put it on the left. We take the inequality that was a greater, we make it a less. The -2 is on the left side, we move it over to the right side. I flipped everything. Okay? So that works for some people, flip everything, they get it. Others are like, yeah, that doesn't work for my brain. So of course I have multiple strategies for everything. I look at this pointy part of the x, it points towards the x. I look at this pointy part and it points towards the x. So I know that I rewrote the inequality correctly. Okay, so if that strategy works for you, use that strategy. Right? Pointy part points to the x, pointy part points to the x. So flip everything, pointy part points to the x, whatever way you use, I don't care. Only thing I do care about is you getting it correct. So if we go back and just look at the 4 examples here, you don't have to write these down. We'll do plenty of problems. Trust me, x is greater than 4. There is no equal to. That is why this is an open dot. And now I want you to notice how they graphed it. I don't want you to graph it that way. Why? Because I get kids that will like make this open dot so small it's impossible for me to tell whether it's open or closed. And if I have any question, I just mark it wrong. So instead of graphing it like they did, make me a big fat open dot above with their arrow going to the right like that. Right? The next one is greater than or equal to, closed dot above, arrow to the right. And I don't need to do the other two, right? That's just a general concept. So don't number the whole number line like they did. All you have to do is write down the single number. That's totally fine as far as I'm concerned. Okay, so first couple of problems on your homework are like this, where you have to look at a sentence and then write the inequality. What I want you to write down here is just this part right here. Write down problem 1 as well, obviously. So you're going to have your first homework assignment here from the textbook. Where it says problem 1, there'll be a group of problems next to problem 1. You can look at this example in the notes to help you with those kinds of examples. We'll not cover every single kind of problem, right? I don't need to spoon feed you everything. Sometimes you got to think on your own. You are all obviously capable of that. So we got to talk about this thing here because it's got a lot going on. First thing, we need to know what at least is. Is at least greater or less than? So helpful hint number 1, you've all got multiple colors. You're writing that helpful hint in the same unique color for like this whole chapter, right? So when you go back and look through your notes, your helpful hints, mine are always going to be in green on this chapter. I might switch it to a different color, chapter 2. But you looking back at your notes and having those helpful hints in the same color each day is important. So at least. Most of you guys are 16 or 17 in this class. We might have some different 15 and 18 or whatever, who knows. But most of you guys are 15 and 16. Or 16 and 17. How many people are 16? Raise your actual hand. How many people are 17? So yeah, we got it. That's pretty. 18, anyone? 15, 14? Okay, yeah, there are some younger. We usually have a couple sophomores in each class. So at least, if I'm at least 16 years old, that was the bulk of you guys are 16, that means I am 16 or greater, right, if I'm at least 16. So at least means greater than or equal to. So if you don't know, again, you get confused. What is that? Is that a greater or less than? Write the words down too. So it's greater than or equal to. Right? You don't have to write that. If you know that's a greater than or equal to, don't write the words. So if I'm making flashcards with this, I never thought I would have to actually instruct people how to make flashcards. But last year it happened to both freshmen and juniors. So I'm like, you must make flashcards for this. I forced them. They had to turn it in as a homework assignment. I had kids that wrote all of that on the same side of the flashcard. And I was like, are you kidding me? That's not how flashcards work, right? You put at least on one side of the flashcard, and you put all of the rest of this stuff on the second side of the flashcard. Things I thought I would never have to say. But so you want to look at your flashcard and be like, at least, and then you think what it is, and you flip it over and double check. That's how you, it's like, I used flashcards to pass my comprehensive exams in graduate school. I probably had like 300 flashcards that I memorized. Because in my graduate school, we had a 4-hour comprehensive exam. We needed to be able to quote articles, know who the author was, and the year that article was published to back up whatever point we were trying to make. And you couldn't have any resource at all. You had to have all of that memorized. I typed 22 pages in 4 hours. Insanity. Okay, so we're 5 fewer than the number is at least 12. So we know we have greater than 12. So I'm going to write that part of the inequality because I know that and I can write it down. So now we need to deal with this 5 fewer than a number. The number part is going to be your variable x. Fewer means subtract. Okay, so we're going to subtract. We have x and 5, and we're going to subtract. Subtraction is unique. With subtraction, you always have to have the variable first, the subtraction sign, then the number. So this is 5 fewer than a number, right? So it's like backwards. So not only is it at least, you would think it would be less, It's not, it's greater. And then 5 fewer than the number, they write the 5 first, but you have to switch the order. So this whole slide is all about opposites, right? What did I say yesterday? Algebra is all about opposite operations. So here's a good example of that opposite operation concept. 5 fewer, it's x minus 5, not 5 minus x. Many students screw that up and say 5 minus x by accident. It's x minus 5. Next one, we have the quotient. Quotient means divide. So if you don't know that, that's a good flashcard to make. Because when you're taking my test or SAT, they'll definitely use words like quotient. If you have no idea that quotient means divide, write it down. So quotient of a number and 3 is no more than 15. So that's another statement we have to determine whether it's a greater than or equal to sign. So no more than. If you're 16 and I'm no more than your age, that means I am 16 or less. I can be 15. 15 is no more than 16. Okay? So when you get confused on these things, you can say it out loud. You can say it out loud in my classroom during a test. I don't care. Right? If it's going to help you get it right, say it quietly to yourself. Make people think you're crazy because you're saying things out loud. So no more than is less than or equal to. If you need the verbiage for it as well, write it. Less than or equal to. Again, you can take your left hand on there, turn it sideways, your left hand makes a less than sign. Okay? So when it's written like this, with the quotient of a number and 3, this is what I visualize with these kind of problems. The quotient, that's my add, subtract, multiply, divide. They could have a problem similar to this that would say the sum of a number and 3, the product of a number and 3. This is the method for these kind of problems. You take that quotient and you put it where the and is. So here's what I mean by that. So remember, the number part is our x. So we have x and 3, and I put my divide sign in between, like that. We have a less than sign and equal to, so less than or equal to 15. Okay, you may see that problem written like that. Remember, all of your quizzes are going to be multiple choice. There'll be an occasional short answer. I have to do that. But you'll have multiple choice. You still have to show work on every single problem you can show work on. You may also see this answer written like this. Either answer is acceptable. You just have to recognize that those two answers are the same. So it could be divide with the old school division symbol, or it could be written like a fraction. Okay, next one. Now we're going to solve for x and graph the equation. So I'm going to write this down. So we'll solve it first and graph it at the end once we have the x isolated. So many students struggle with that what do I do first concept. This is a great example of what the hell do I do first. So I look at this thing, I kind of think of this whole expression right here as the variable, okay? So I want to get this purple highlight by itself. First thing I want to do to get that purple highlight by itself is get rid of this 1. To get rid of the 1, opposite of positive 1, subtract 1. So we have negative 3 times the quantity 2x minus 5 greater than or equal to 4 minus 1 is 3. So when I see problems like this, I want you to think along the way, right? You're actively participating not only in my class, but you're actively doing these problems. Because sometimes it's easy to turn into that math robot, where you know how to do a bunch of math and you just crank through the problem and you don't honestly really think along the way. I always want you thinking, anticipating, trying to figure out how the problem's going to end, so that if something goes wrong, it's a good indication that, oh God, I screwed something up. So I look at this and I think, I've got two options here. I could either take that -3 and distribute it into the parenthesis, but the implied operation in between the -3 and the parenthesis is multiplication. To undo multiplication, I can divide. So then I look over here at this 3, and if I divide by 3, I get a whole number over here. So I'm going to do that, because if I distribute, it's going to cost me at least 2 more steps on the problem. And I try to do every math problem, and hopefully you will too, the easiest possible way. So if I divide here, that's easier. So I'm going to divide both sides by -3. Anyone remember what happens to an inequality when you divide by a negative number? You can unmute and tell me. When you divide by a negative, what happens to the inequality?
What's the sign?
Flip it. Right. Flip the inequality when you divide by a negative. Oh, what a great helpful hint to write down. So when you multiply or divide by a negative, it works for both of those operations. Add and subtract doesn't matter. Multiply and divide does. When you multiply or divide by a negative, you want to flip the inequality. Okay, so we're just going to switch it from a greater than to a less than sign. So when you get rid of the number in front of the parentheses no longer matter. You do not have to write them anymore. So we end up with 2x minus 5 greater than or greater than or equal to, oh, I forgot to flip the inequality because I'm just that smart. Less than or equal to is what I meant to say, -1. And then it's a little baby 2-step linear equation. Why is that a linear equation, you might ask? If you didn't think that, you should be thinking that. It is a linear equation because this is x to the first power. When I get things that are x to the first power, they make a line. If it's x to the second power, they make a u, or an upside down u. During this year, we'll get to cubic, quartic as well. You'll see all sorts of crazy stuff that goes down. This we're going to graph on a number line, though. I just wanted to point out the fact that that is a linear equation. We're isolating the variable by adding 5 to both sides. So we get 2x is less than or equal to. So again, as I was talking about yesterday, when I look at this part of the equation over there, I can think it like -1 plus 5. I find it much easier to think of it as 5 minus 1. 5 minus 1 is 4. So 2x is less than or equal to positive 4. Divide by 2 for my last step. And we get x is less than or equal to 2. Okay, when we graph this sucker, all you got to do is draw a line right at 2 below. Like I said twice already, now for the third time, do not number your whole number line. That's a waste of your pencil. It's a waste of your ink if you're doing it in pen. Right? So we have a closed dot. We have a closed dot. Why? Because we have more stuff. We know that our inequality arrow points to the left. The pointing part points to the left. So our arrow goes to the left. Right? Pointing part points to the left, pointing part points to the left. Easy as pie. So that's all you got to show me for graphing these things. All right. Try this one on your own. I'll give you a minute or two. Look for that opportunity to divide that negative 2 out. I'm not telling you whether you can or not, but if the last one you could, again, we want to anticipate what's going to happen in math class because it makes your life easier. So if you could divide that negative 2 out on the previous problem, I'm guessing we'll probably be able to divide that negative 2 out in this problem. If you want to distribute, because you like doing that better, distribute. You'll still get the right answer. You just spend 2 more steps than I do. That's all. No big deal. So as you're cranking on that problem, I always like to talk to you about many things that are not necessarily math related. The thing I want to talk to you about right now is taking care of your noggin, right? Taking care of your brain. Being stuck at home for the bulk of your life is a drag. It can make you anxious and depressed. What will help you if you are anxious and depressed is to get outside and get some sunshine on your face. And I don't care if it's negative 20 out, go outside anyways. You all have good clothes to wear, hats and gloves and stuff like that. Like I play golf every single month of the year. I like to walk when I play golf because I get a 7-mile hike in. I carry my bag, so that's like 30, 40 pounds on my back. I love doing that. Now I belong over at Omni Interlaken. I don't know if any of your parents are over there. When I play competitively at Omni Interlaken, I love nothing better than to beat your parents on the golf course and take their money because it's entertaining, right? But a lot of those old guys over there at Omni are fat. They can't walk, which is a drag. In the summer, I can't walk because nobody will walk with me. And I'm in shape. I pride myself in fitness, so it bums me out that I can't walk. Moral of the whole story is, get outside, get sun on your face, it helps you become happy, right? We've got beautiful mountains over here, right? Flatirons. I hiked Green Mountain on Monday, right? I post my asynchronous stuff, and if I'm done with my grading on Monday, I can grade whenever I want. So I take advantage of these beautiful days, and I'll go for a hike. I hiked Green Mountain, took me an hour and a half up, about an hour down, and it was spectacular. Right, met some crazy old couple at the top, took their picture. I'll show you a picture along the way. I actually had an amazing experience because I got a selfie with a deer. I'm walking up, I'm playing song on my phone, and I saw these 2 deer like right next to the trail, and I was like, hey buddy, it's all good, it's cool, like don't run away, and they were totally chill. They were looking at me, this deer, and I was like, oh my god, they're going to stay right there, because normally they bolt. I took a couple pictures up close, I'll show you eventually, and then I started hiking up the trail, and I was like, wait a minute, those deer were so chill, I may as well try to get a selfie, and I kid you not, I got a selfie with this deer that was like 4 feet behind me. Unfortunately, my picture, I was kind of excited to take the picture. I look like I'm just high as a kite in this picture. I swear to God I'm not stoned. Hiking on ice stoned would be a terrible idea. But it's a super cool picture, like the deer is right over my shoulder. Nuts. Okay, so you should have answered that after my little story time. You should be good. I'm going to do the problem now. Negative 2 parentheses x plus 9 plus 5 greater than or equal to 3. When I have you guys do these problems, I do this super fast. So hopefully you have your work down and just make a correction or two. But we go fast. So subtract 5 from both sides. I know that 3 minus 5 is going to give me an even number. I know that that negative 2 in front of the parenthesis is also even. So I'm already thinking, right? I'm trying to teach you that anticipation in these problems that I'm going to be able to divide an even number by an even number. So I'm just kind of thinking along the way. So I'm trying to get you guys to do. So negative 2 times quantity x plus 9 is greater than or equal to negative 2. So yes, I'm going to divide that negative 2 out. They're both even. They are both the same number even. This makes it easier to divide. So I'm dividing by a negative. I need to flip the inequality. Right? Write that stuff all the time so it gets into your brain so you remember to do things like flip the inequality. We get x plus 9 is a less than now or equal to positive 1. Last step, subtract 8. 1 minus 8 is negative 7, so x is less than or equal to negative 7. When I make the graph, just write negative 7. Again, we have more stuff, close dot. Pointing part goes to the left, pointing part goes to the left. Then.
Yeah, that's what I was going to ask.
Oh, subtract 9, thank you. Thank you for telling me I screwed up, Amanda. I subtracted 8 because I'm tired. I will fix it.
And then, wait, hold on.
Yeah. No, always tell me x is less than negative 8. I was close. I was only 1 off. That's a good. I wish I would actually left that up there as well. So let's say you two, well, if you're taking a quiz, you're going to have multiple choice answers. Unfortunately, what these multiple choice answers do is they anticipate you guys making these little careless errors. So they'll do things like not flip the inequality as one of the answers, right? And you think you got the problem correct when you actually didn't. So just know that that kind of stuff goes down. That's why you're going to submit your work when you take the quiz on Monday. So if you make a mistake like I did and you're 1 off, I would probably give you 3 out of 4 points on that problem, okay? Because you did, like I made one stupid little mistake. Clearly, looking at the work I showed, I know what I'm doing. I just made a careless error. So I grade your stuff based on like the percentage of knowledge you demonstrate. Like I made a stupid mistake, so I was able to demonstrate like 90% of the knowledge on that problem. So I should get 9 out of 10 if it were 10, or 3.5 out of 4. Right? I'll just take a half point off for a little mistake like that. Up to a point. It just kind of depends. Okay. We got story problem. We have story problem method. Our first step in the story problem method is read, don't write. Movie rentals. A movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? So we got 2 plans. Now, raise your actual hand if you already think you know what the variable is? You can give me one of these if you're like, I think I might know, but I'm not totally sure. Okay, so second step in the story problem method is read and highlight. So that's what we're going to do now. A movie rental company offers 2. So I want you to write down what I highlight. So 2 plans. You can pay $36 a month, and you can rent as many movies as you want. So that's plan 1. Plan 1, I'm leaving in that blue highlight. I'm going to change highlight colors for plan 2. So plan 2, $15 a month, and $1.50 to rent each movie. So plan 1, blue highlight. Plan 2 is green highlight. So we can even match the colors to the highlight colors, because I feel like being extra psychotic about my organized use of color today. So plan 1 is just straight up $36 a month. Plan 2, $1.15 a month plus $1.50 to rent. So we need to identify the variable. When I did this problem last period, I screwed up, and I said the variable was month. The variable is not month. The variable is movies. So x equals movie is the variable. So you've done the first 3 steps of the story problem method. Step 1, read, don't write. Step 2, read and highlight. Step 3, identify the variable. Now we got to write the equation. So plan 1, they just told us it's $36 a month. Plan 2, I'm purposely leaving the inequality out for now. I think that's some of the failure you guys have with these story problems, is you want to write it all right away. Like, just write what you know and then figure it out. You might screw it up and have to get your giant eraser out and erase, right? That'll happen. So 15 plus $1.50 for each movie. So that's just kind of how the plan like how it naturally led me to write this down. And I don't like it already because I like the variable to be on the left side. So when I write my equation, I'm going to make sure my variable is on the left side. So again, writing our equation here, we're like nuts and bolts of the equation up top, and we're going to write the equation we solve right down here. So $1.50x plus 15. I'm leaving the gap because I still haven't even thought what the inequality is yet. You may have already, you may know what the inequality is. I'm just doing it my way. You can do it your own way, that's fine. So now I'm going to go back up and look at the problem and try to figure out which way that inequality goes. Because I think it's kind of confusing to figure out which way it goes. So how many movies must you rent in a month for the first plan to cost less than the second plan? So we want the first plan to be less, so the pointing part's got to point towards that first plan. I always like to look at the homework on these. I'm looking at the story problems right now to see if there's any other weird crap they pull on you. There's a consecutive integer story problem. You're doing every other of those, so that won't be on there. Yeah, the other one you're going to do, I think, is just like this one, so that's good. Okay. So the textbook has this inequality pointing the other way. So they have the inequality, the pointing part pointing to the 36. Okay? So it says how many movies must you rent in a month for the first plan to be less than the second plan? What do you guys think? Should the inequality point the way I have it or the other way? Who can argue why the inequality should point the other way? Unmute and tell me why you think that. I know there's somebody in here that'll do that. I like it, Amanda. Opposite. Everything's opposite in this damn class, right? So I thought it was going to go that way, but it actually goes the other way. I'm going to leave it and solve it, because this will happen to you, right? I'm like unsettled, unsure which way the inequality goes. Guess what? That happens all the time. It's no big deal. Let's solve it and kind of think about the answer once we get to the answer, because it might make more sense then. So we're going to subtract 15 from both sides. We don't have to flip the inequality because we're just subtracting. You only flip the inequality when you multiply or divide by a negative. So 1.5x in mine is less than 36 minus 15 is 21. Last step, divide by 1.5. So you get x is less than 21 divided by 1.5 is 14. So 14 movies. Okay, so what I'm going to do is I'm going to plug that 14 in. So, and let's write the equation 1.5 times the 14, right? Plug in that 14 in right there, plus 15. I thought it was less than 36. The book thinks it's the other way. We'll see which one makes more sense. So 1.5 times 14 is 21. Right? So I'm just looking at what I have on the calculator, and I know if I go 14 over here times 1.5, I should get that 21. Always double check, why wouldn't you? So 1.5 times 14, it's just the opposite, right? Like Amanda said, everything's opposite. So 21 plus 15 is less than 36. So what happens there is 36. Oh boy, I didn't issue on my 6 there. 36 is less than 36. So I'm just playing around with the problem at this point, trying to figure out which way the damn inequality goes, right? Because and I've been teaching math for a long time, right? And it's still weird. with the inequality. So 36 is less than 36. We know we have 14 movies. So let's think about this thing. So right here, this side was plan 1. This side is plan 2. So in our story problem method, we identified the variable, we wrote and solved the equation. Now we're at the trying to answer the question portion of the program. So the question was, how many movies must you rent in a month for the first plan to cost less than the second? How many plans do you have to rent, or sorry, how many movies do you have to rent in a month? Show me with your hand. Zip. Hand zip. How many? Yeah, 14, right? So here's the thing. Does that inequality actually matter? Doesn't really matter, right? So I don't give a rat's ass which way the inequality faces. Like, we're still good. We got the answer, right? So 14 movies for the plan to cost less. I can't remember what it's first plan to cost less than the second. So again, that's a good indication. I wanted to kind of struggle through that problem with you. It's way better if we can do this kind of thing in person, because I can get you guys talking more about it and we can talk about it. So I'm just giving you what I think in my head to help solve this thing. But we got the answer. How many movies? 14 movies. Okay, next one. Sometimes, always, never true. Your favorite and mine. Sometimes, always, never true. So we got this problem here. Write that sucker down. -2, 3x plus 1. Again. 3x plus 1 greater than -6x plus 7. So I'm looking. Can I divide that -2? Implied operation between the -2 and the beginning of the parentheses multiplication, which I can undo by dividing. So I look at the right side of the inequality and think, are both of those numbers divisible by 2? The answer to that question is no. 7 is divisible by 2, but you get a decimal. We don't want to deal with decimals right now. So we are going to distribute the -2 into the parentheses. Again, showing you how to think, how I approach these math problems to inform your judgment when you too look at how to do these math problems. -6, -2 times 3 is -6x, -2 times 1 is -2, greater than -6x plus 7. So if I solve this thing and I add 6 to both sides, those -6x's cancel. Then I want to determine when my variables go away, does it make a true statement or not? So I look at this -2. Is -2 greater than 7? So sometimes when they do greater than and 7 in the same problem, it helps to put that little slash thing through your 7 so you can make sure you don't mix up the inequality in the 7. Sometimes mine will look almost identical. So is -2 greater than 7? Yes or no? Shake your head. Is -2 greater? Hell no, no, it's not greater. So that is never true. Right? This made a false statement. So when you get a false statement, it makes sense that it is never true. A false statement doesn't make sense that it's always true or sometimes. It's got to be never. -2 is never greater than 7. Okay, next one. Again, sometimes, always, never. So we got 5 times the quantity, 2x minus 3 minus 7x. Again, they use 7s all the time. This book's kind of irritating like that. They'll use 69 and 420 all the time as well. I'm hopeful because we have a 2-day Pi Day this semester coming up that will break that 69 Pi Day record. You guys will bring in at least 70 Pi, so I don't have to still have 69b, although it is kind of funny. But, you know, I'm like, my God, are you kidding me? So add 7x to both sides. Again, I'm treating this whole kind of variable expression here as an x. I want to get that whole expression part by itself. I do that by, actually no, I don't want to, I take it back. Don't add 7x. I'm kind of thinking along the way. So I'm going to distribute. The reason I just changed my mind is because when I distribute, I'm going to have two x values on the left side of the inequality, and I can combine like terms at that point. I think it's easier to combine like terms first, so let's do it that way. So 5 times 2x is 10x. 5 times negative 3 is negative 15. Minus 7x, less than or equal to 3x plus 8. So some of you guys that struggle in algebra, you're looking at this problem like, oh, Jesus, man, this is just not fun. Just one step at a time, chill, it's going to be okay. Use your colors, slow down, right? It's just a couple more steps when they add more stuff to the problem. It's not that big a deal. So we can combine 10 minus 7 to get 3x. So we have 3x minus 15 less than or equal to 3x plus 8. You can see why I changed my mind, because that's a lot cleaner, right? If I subtract 3x from both sides, those cancel and I'm already done with the problem, essentially. Negative 15 is indeed less than positive 8. So that is always true. Is negative 15 less than 8? Yes. So, actually, I want to check one thing. So I think the textbook will tell you no, they say always true. So this is one I don't like, right? So this sign right here, this is where I argue with the textbook. Like, I think I'm smarter than the people that wrote the textbook. I'm definitely not smarter than them, but this is how I think you can argue both sides. So this green highlight here is a less than sign. So it's later on when you do these compound inequalities, you'll need to know this. When it's less than like that, I write it like less than, meaning it's an and inequality. In and inequalities, in my mind, it has to satisfy both parts of the inequality. Negative 15 is less than 8, but it's not equal to 8. So I don't think this is always true. In my mind, this is sometimes true. The book says always true. So how the hell does that make sense, you might ask? If you plug in variables here, right? So let's say I plug in 0. It makes a true statement because negative 15 would be less than 8. Let's plug in 1. 3 times 1 is 3. 3 minus 15 is negative 12. So I got negative 12 for the left side. I plug in 1 over here. 3 times 1 is 3. Plus 8 is 11. Is negative 12 less than? Right? It's not going to be equal to. So that's why the book says this is always true. But I hope you can understand my point. It's not equal to, so that's why I have a little bit of a problem with it. But the book will say this is always true. So that's how you need to think about these things. Again, in math, you guys oftentimes want these absolutes. Like, that makes crystal clear sense. I 100% get it. And it's not always the case. And stuff gets weirder and weirder as you get into more difficult math. It gets way more abstract, and it just gets funky. Trust me. So that's always true. Now we're to these compound inequalities. We have an and inequality right here. So, and inequalities, you're going to graph both of these equations on the same line. So once you solve for x, we're going to graph on the same line. When it's an and, the arrows tend to connect. When it's an or, the arrows tend to go out. Does that work 100% of the time? Of course not. But in general terms, 90% of the time, maybe 95%, it does. And inequalities connect, or inequalities point out. So we're going to write this. I'm going to switch that first inequality to put the variable on the left so that I can use my little strategy that the inequality arrow and the arrow on my graph will point the same way. So again, I'm going to switch everything. 2x plus 1, this is a less. I'm going to make it a greater. And then, again, this book uses a 7. It's like they're insane. So the other strategy in figuring out how to rewrite these is that the pointy part points to the 7, pointy part points to the 7. Then you know you wrote it correctly, right? So you can think of it like that too. I like writing the and shockingly organized use of color and a big fat red right in the middle. Just so I remember when I graph, my arrows should connect. And then sometimes they won't, right? But almost all the time they will. Second equation is 3x is less than or equal to 18. And then we just solve. Usually when they give you these compound inequalities, they're not particularly difficult ones to solve. So we're going to subtract 1 from both sides. On the first one, we get 2x is greater than 6. Second one, we're going to divide by 3 on both sides. And we get x is less than or equal to 6. First problem, second one's done. First problem, we got one more step, divide by 2. We're dividing by a positive number, so you do not have to flip the inequality. So we have x is greater than 3. Remember, this is an and inequality, so I'm thinking the arrows will most likely connect. When I graph these compound inequalities, small number on the left always, big number on the right, like any old number line. Now, if that freaks you out and you want to put some numbers in between the 3 and the 6, go for it. I'm lazy, right? I want to do it the quickest way I can, so I do it like this. So I look at my inequality arrow on the 3, that arrow points to the right. That is just greater than, so I have an open dot, and I know my arrow points to the right. So I'm not going to make them connect all the way just yet. I'm going to kind of think about it and make sure I didn't screw it up. I look at my second inequality. That arrow points to the left. I also have an equal to. I have more stuff, so that is a closed dot. So I make a big fat closed dot right there, and my inequality arrow points to the left, so my arrow points to the left. Okay, so I know then that my arrows do connect. You don't have to go through and do that little arrow thing like I just did. You can just think about it and connect the dots. If I do this problem, that's how I would do it. I'm just showing you like everything that goes through my head in the hopes that you'll get more of these problems correct. Okay, so shockingly, they have an OR one next. Again, we try to anticipate what's going to happen, right? I want you to be thinking about how I teach this class, trying to anticipate the kinds of problems I will put on your quiz. You do that because it makes your studying more efficient. So this is an OR. We've got 7 plus k. Can I switch the order of the 7 and the k? Shake your head yes or no. Can I switch the order of the 7 and the k? Yes, I can. We have the commutative property in math where you can switch the order, especially with addition. Just flip it. So if you like the variable first, do that. If you don't care, just write 7 plus k. I'm going to put the variable first. Again, they use a 7. It's unbelievable. K plus 7 is greater than or equal to 6. I like overemphasizing that or, so I remember that my arrows are probably going to point out. So here I have, I'm going to switch the order on the second one again, k plus 8, using the commutative property. And this is a one-step linear equation because the variable is to the first power. So all we have to do is that one step. On the first, subtract 7. On the second, subtract 8. First one, what I get is k is greater than or equal to 6 minus 7 is negative 1. So when you guys miss that kind, like you screw up subtracting 6 minus 7, I get angry. So check that kind of stuff in your calculator, especially if you get a negative. I can't tell you how many students will tell me that's positive 1, so just double check. And again, if you suck at negatives, you just think, here I am at positive 6, my zero's over here, I subtract 7, I go that way. It's got to be a negative number, because I'm subtracting something greater than where I started at, right? So it's got to be a negative number. So again, that quick little number line will help you with those negative issues. So over here, again, we have an or. I'm annoying how I emphasize that, right? I keep writing it over and over again. You should do the same. So k is less than 3 minus 8 is negative 5. Again, think what it is in your head, double check on your calculator. Now, when we graph this, this little funky thing happens with the ors when you graph. First funky thing that happens is negative 5 is smaller than negative 1, contrary to some of what you guys believe. Negative 5 is smaller than negative 1, right? 0 would be over here. So it makes sense now that negative 5 is smaller than negative 1. You don't have to write the 0. So when I graph this thing, notice that I graph the negative 5 on the left side, and I graph this negative 1 on the right side. So you've got to just realize that so you don't screw up your inequality. So k is less than negative 5, pointing part, right? Inequality arrow points to the left. That's just less than, so we have an open dot. My inequality arrow points left. My arrow on the graph also points left. I look over here. I have a greater than that points to the right. I also have an equal to. I have more stuff. More stuff, close dot. Arrow to the right, boom, boom, arrow to the right. Okay, the arrows did point out on the or inequality. It happens like in this textbook, because it's a regular Algebra 2 textbook, easily 95% of the time, the arrows will make sense. The other, you just got to think about it. It doesn't happen that often, so I'm not going to emphasize it in the lesson. But if you get a problem that I didn't cover in the lesson, I'm going to show you the solutions, how to use them today when we have book pages, so you can kind of help learn more math than I teach you. Because I can't teach you how to do every single kind of problem. You're going to have to figure out some of it on your own. That's it. That's the homework. Woohoo! Okay, let me show you the homework real quick. So, go down to week 1. Easiest place to look for the homework is in that calendar. And then it's not there. Of course, it will be. Or, because that can happen, we look at week 1. So there's the homework 1.5, solving inequalities. That's what we did today. So it's page 38. You could get a blank page in your notebook and write it down right now. So page 38, 11 through 51, every other odd. It is super helpful for me, and I'm going to tell you this now. I'll write it on the Schoology homepage as well. When I grade stuff, it's really helpful if you put your first name and last name on your paper when you take your little picture, and you put your period. Because I grade stuff like I was grading stuff as I was watching a movie last night because it's easy. It doesn't take a whole lot of brain power for me to grade. So I'm flipping back and forth between a bunch of classes. It just makes it easier if I see your period on there. Question? Mitchell?
We're going to write period 6, right?
Yeah.
Technically 6 period.
Technically 6 period, yeah. 5, 6, 7, 8. So yeah, write period 6 on there. It's just helpful. So what does every other odd mean? Every other odd means you do 11, skip 13. I wrote it in the little description below. do 15, skip 17, do 19, etc. So when you're doing one of these, click on the assignment. You already know that. You can view the book page. So this is just like a screenshot from the online textbook. It loads super fast. That was sarcasm. So boom, there you go, you got it. So this is, you can tell it's pretty clear. When they redid the textbook or screwed it up, it's all blurry now. So I'm super happy I have all these PDFs already. The other thing I want to show you is the solutions. So right here, solutions, and you can kind of see how those solutions work. So I only put down the problems that you do. Do 11, skip 15, skip 17, do 19, like that, right? So the solutions will show you, if you look at 21 right there, they'll show you the steps of the problem. Yes, you could just copy it down. Guess what? I can tell when you just copy it down, and I give you 0 and I mark cheated on IC. So don't just copy it down, because yeah, I want to see your work on every single homework. And like I said, your homework, it was impressive. I was showing my stepkids your guys' homework last night, and they're like, oh my God, they all write so neatly. So you guys got props even from my stepkids. And my stepdaughter, the freshman in high school, she actually said this to me. She goes, because I grade with my iPad, and I'm like, I got the little trackpad, and I'm moving stuff around in different windows. It's all crazy. She's like, oh, it looks like fun. I'm like, no, it's not fun. Grading is the worst part of my job. Working with you guys is the best part. Teaching is the next best part. Anyways, you see the steps in the problem, so if you get stuck, you can look at it, right? So I have the book page one tab, and you're going back and forth between the book page and let's say you didn't know how to do number 11, then you're checking in the solutions, looking at number 11 and going, oh yeah, at least it's greater than or equal to. I knew that. And product means multiply, right? So then you can learn more math than I can actually teach you by using the solutions. The notes posted right here are the notes from last year. The notes that I will post, if it allows me to click on it, the notes I will post in the notes folder, the little green folder on the School of You homepage will be the notes from this lesson, okay? So if you want this year's notes, click on that notes folder. If you just, you know you're going to miss and you want to write some notes down, their notes are virtually identical year to year. I will change some stuff, but it's close enough for your purposes. So you got the rest of the time to work on your homework. You can start right there. You can pull it up on your own computer screen. When you do your homework, you can have your camera off. When you leave the class, if you finish your homework, be a nice human. Say, bye Adams, have a nice weekend, because I will say the same to you, right? I had my last class, everyone just left. One kid said bye, and I was like, oh, that's not nice. So say goodbye, be a nice human, right? We're all here to be nice to one another. There's enough crazy crap going on in our world. Alright, that's it. I will have the lesson posted as a video. It takes like 20 minutes for YouTube to handle it. But yeah, you can turn your camera off. If you have questions on the homework, you can write it in the chat or unmute real quick and ask me a question.